In order to solve equations, we must know about the inverse property. And the inverse property simply says, take the opposite. If I have A and I add to it the opposite of A, they will cancel each other out and equal 0. If I start with negative A and I add to it its opposite, again it will cancel to equal 0. Trying that with numbers, if I have 3 plus a negative 3, they're going to cancel and give me 0. So the opposite of addition then is going to be subtraction. And the opposite of subtraction would be addition. We're going to show this in two different ways here. We're going to show it on a balance, and then we're going to show how to solve algebraically. In order to understand the balance method, we need to use some symbols, and we're going to use yellow for positive, red for negative. So every time I have a red and with it a yellow, those two together are going to literally just cancel each other out and add to 0. So here's my balance. My balance, this is the equal sign, and we're going to split this equation into a left and a right. So we have the left-hand side of the equal sign and the right-hand side of the equal sign. And our goal is to be fair in what we do to the left and do to the right. Here's our first problem. If I had to ask you what number plus 3 is equal to 5, 2 plus 3 is equal to 5. I'm now going to show this equation, x plus 3 equals 5, using symbols. This is going to represent my x. Positive 3, we'll use 3 yellow dots. And for positive 5, 5 yellow dots. And notice they're on the right-hand side of the equal sign because 5 is on the right-hand side. My goal in solving the equation is to know what x stands for. This box represented x. So to know what x stands for, I need to get it all alone. On the left-hand side, I'm going to put 3 red dots because the opposite of 3 yellow is 3 red. The opposite of 3 positive is 3 negative. If I put 3 on the left, I need to put 3 on the right. A positive and a negative cancel each other out, so I cancel on each side, and my single x is equal to positive 2. And that's what we found just mentally when we looked at that. Now we need to look at it algebraically. I want x to be isolated. I want x to be all by itself. So I need to get rid of that positive 3. So I'm going to subtract 3 from each side. So when I subtract 3, I must do it to the right-hand side as well. X equals 5 minus 3 is 2. So there's 3 representations of solving a one-step equation. Trying the next equation, what number minus 2 is equal to negative 5? That would be negative 3. A negative 3 and a negative 2 is a negative 5. A little bit more difficult to see than the first problem. Representing it on the balance, I have 1x. I have a negative 2, which would be 2 red, and a negative 5 on the right. My task again is to get x by itself, so I'm going to put 2 yellow. On the left, I need to balance, so I put 2 yellow on the right. The inverse property allows me to cancel those out and equate them to 0. On the left, I have a simple x. The equal sign is the center of the fulcrum of the balance, and I'm left with 3 red. Red means the 3 are negative. Solving it algebraically, on the left-hand side of the equal sign, I want x alone. I need to add 2 or the opposite of minus or subtract 2. I add 2 to the right to balance. Left-hand side is x equals $5 in the hole. I get $2. I'm still in the hole, $3. And the last problem, what number plus 4 is negative 2? Negative 6. If I'm $6 in the hole and somebody gives me 4, I'm still in the hole, $2. showing the equation on the balance, x. Positive 4 means I have 4 yellow. Equal sign is the center of the balance, and on the right hand side I have 2 red. My goal is to isolate x to get rid of the 4 yellow. To balance, I'm going to put 4 red on the right. What I do to one side, I must do to the other to maintain the balance. The inverse property with respect to addition sums those to 0. X on the left, and I have 6 red on the right, 6 red, negative 6. Solving it algebraically, my equal sign, I want x to be by itself, so I must get rid of the add 4. I do that by subtracting 4. So when I subtract 4 from each side, x is equal to negative 2 and negative 4 is negative 6.